Jared, it is so good to have you back on our podcast finally, because I'm not sure I can go on and continue to do these by myself. Sitting here alone in the closet is just not as fun as it sounds, I promise you.
Good. Well, I know we are going to have a riveting topic today,
Oh
so
yeah.
I'm super excited to get into the nitty-gritty. But I think it's if anybody can make it interesting, I hope we can.
Well, we're going to try. It is episode 62 of the Rule Your Pool podcast, and today we are talking about how to adjust total alkalinity. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. All right, Jared, if you have high alkalinity in your pool, what can you add to it to reduce the alkalinity?
Acid.
Oh,
All right, we're done.
yeah, that was pretty much it. Yeah, I mean, thank you everybody for listening to this. Has been episode 62.
Yeah, you're
Okay,
welcome.
now but there's a few types of acid, and some of the questions we get on the hotline are, well, I use dry acid, or I can't get muriatic acid. What can I use? And there are a few options. So the most common, of course, is muriatic acid. There's also sulfuric acid, and there is sodium bisulfate. Now, both of those alternatives contain sulfates. And some people have asked, well, can't I reduce pH with CO2? And the answer is yes, you can inject CO2 to reduce pH, but that does not reduce your alkalinity. We have a whole episode on CO2 and Henry's Law and all of that. And if you want to go back, you can listen to it. If you are going to reduce alkalinity, what you have to do is you have to convert it into basically carbonic acid. You have to burn through it. And that's how acid actually reduces the pH. When you put acid in the pool, it adds hydrogen to alkalinity, converts it into dissolved CO2, which is carbonic acid, and that is what pulls down your pH. At least I think in my head that sounds right. Jared, is that your understanding of it too?
Yeah, that cool little chart that we made that has little crossing lines with the pH scale on the bottom that I never really understood until we broke down the differences of carbonic acid,
That's fair.
bicarbonate, and carbonate. That's exactly what we're talking about here. You're taking in the alkalinity from a bicarbonate state, or I guess a carbonate state, and bringing it down to a carbonic acid state, which in turn lowers the pH and reduces alkalinity. Yeah,
Yeah, well, for those of you watching on YouTube, check it out.
that's the
Look what I can
one.
do now. We're actually doing this one on video, folks, if you're listening. We have not been on video much, and we hope that Zoom doesn't fail us this time. But what I'm showing on the screen here is the alkalinity equilibrium in swimming pools. So I guess now that this is up here, perhaps we should give a little context for what we're talking about. If you are a homeowner listening to this and you don't actually know what alkalinity is, it is basically the buffering capacity of your water. Primarily, alkalinity, according to the IPSA Intermediate Training Manual by Robert Lowry, a wonderful book if you've never read it, it is all dissolved alkaline materials in your water, primarily made up of carbonate ions, bicarbonate ions, and hydroxides. Secondarily, you also have cyanurate alkalinity. If you use borate, borate contributes to it as well. Nitrates do, and sulfates do. And well, at least that's all that's mentioned in this book. There might be a few others. Those are not major ones, though. The major ones are carbonate and bicarbonate. And this chart shows us that the vast majority of alkalinity in your pool is going to be bicarbonate.
Correct.
The way that acid reduces pH is it adds hydrogen to bicarbonate or carbonate and converts it into dissolved carbon dioxide. That is what pulls your pH down. That's why we say in other episodes, because it's the truth, the amount of CO2 in your water effectively determines your pH. The more dissolved carbon dioxide you have, the lower your pH. The less, the higher your pH. So you have a lot of carbon dioxide in your pool, it's just in the form of carbonate alkalinity.
Now, let's clarify on that because you're throwing around the word carbonate alkalinity, and then in the pool test kits, we test total alkalinity.
Yeah.
And we have an app, obviously, for those of you that didn't know. Um, it wants you to input the total alkalinity into the app, just FYI.
Mm-hmm.
And the reason why you do that on the app is because we already make the calculations for you, and the carbonate alkalinity is already considered, just FYI. So when you're using the app, input total alkalinity.
Yeah.
But what's the difference?
Well, what we're asking for, it's a great question. So the total alkalinity is what you test. Okay. The carbonate alkalinity is the primary types of alkalinity, which is the total of all of your bicarbonates and your carbonates and your hydroxides. But there's so few hydroxides that are measured, it doesn't really make that big of a difference, at least according to this book. So it's really the sum of your carbonate and your bicarbonates. And that equilibrium we just showed is considered carbonate alkalinity. Effectively, what that means for the LSI, when you're measuring the holistic balance of your water, you have to deduct those secondary types of alkalinity, primarily cyanuric alkalinity. The way you do that is there's a reference chart at a given pH. It's roughly a third of your cyanuric acid level deducted from your total alkalinity. So if you have 60
to get your carbonate alkalinity,
or well, let's call it corrected alkalinity, but yes, carbonate alkalinity, aka corrected. And this is where people get confused. In fact, we have a blog just about it. If you are on the app, go to articles, type in the word carbonate, and you will find an article that says carbonate versus corrected alkalinity. That explains because yes, we have carbonate ions, and that carbonate CO3 minus minus can get confused with corrected alkalinity because they're both called the same thing. That's what gets so confusing. At least it confuses me. Everybody get all that? Good. Let's move on.
Yes.
So, I know it's ridiculous. I mean, I actually, in that article, I make the case, we should just call it the corrected alkalinity. Take a third of your CYA. Let's say you have 60 CYA, a little bit high, but it's easy math. What's a third of 60, Jared? Quick math. Go.
Ooh, 20.
Oh, yeah. A+. Yeah, I know. We would have had to edit that out if it took too long. So you're going to take 20, which is a third of your CYA, and deduct that from your total alkalinity. So a lot of the people that call us about like flakes in their saltwater pools or anything, one of the first questions that we ask at Orenda is, what's your total alkalinity? You might have too much.
Yeah. If I'm being a good, studious, nice, follow the rule service technician, I'm keeping my alkalinity at 100, right? Total alkalinity at 100.
Right, because the textbook tells you 80 to 120.
Absolutely. It's right in the middle. So after I deduct the cyanuric acid factor, my corrected or carbonate alkalinity is 80.
Yes, sir. You got it. That is the number that plugs into the LSI formula. Now our app,
not on ours.
I know, but on our, yes, it does on ours. On our app, you input the total alkalinity, and when you adjust the cyanuric acid on the app, it automatically makes that correction behind the scenes. You just don't see the alkalinity change, but it is using the corrected alkalinity for the LSI. If it didn't, when you went and upped your CYA, nothing would change on the LSI. So that's what's actually happening. The CYA is just multiplied by a pH factor. So it's approximately a third, but it could be 0.31, it could be 0.34, depending on the pH, and it is deducting against your total alkalinity. That's what's going on. So I guess we could have done a full episode just explaining what alkalinity is, but you know us, we're very professional here, and we are clearly going down a rabbit hole. So I'm going to try to recover this episode and get back to the point of it of how to adjust it. You said you can reduce your alkalinity with acid, and you're absolutely correct. Let's talk to the audience about how that should be done. Do you just pour it straight in one spot, Jared?
If I were a good, studious service technician, I would absolutely follow the column pouring method, but I don't want to do that.
For those listening, what is the column pouring method?
I'm making fun of this because I've been guilty of this as well, everybody. So I say it with a little tongue in cheek here because I absolutely 100% prescribe to the column pouring method, which is, well, if I stand in the deep end and I pour my 32 ounces of acid directly in this one spot, it's going to sink and burn alkalinity better than if I were to walk it around or dilute it into a bucket. And we've realized after getting into chemical manufacturing and research, I guess, and by other people who are just smarter than us have told us the same thing.
Straight up. There's no sugarcoating that one. They are.
Yeah, they're smarter than us, and it's a myth. It's 100% myth. Column pouring does not work. It reduces the same amount of alkalinity as diluting in a bucket, pouring in the water, and just getting X amount of acid in the water is the main goal.
Alkalinity is a linear thing. It's parts per million. You either deduct it and cancel it out with acid, or you don't. So whether you pour it straight in one spot, or you walk that bottle around the perimeter, or you do the right thing, which is dilute that acid, you're still getting the exact same amount of acid in the pool, and you are deducting the exact same amount of alkali. That's the key. What really matters here is the column pouring method was originated because people didn't want to reduce their pH that much. And so in these plaster cement type pools, if you column poured, the illusion was, hey, I can tank my alkalinity where I need it to be without reducing the pH too much. But we've seen the food coloring. We did an experiment with it in a mason jar, but we got that idea from On Balance, where they put food coloring in it in an 8-foot pool, and we have those photos. Acid goes straight to the bottom of the pool. Muriatic acid is 18% denser than water. So, Jared, what do you think it's doing to the plaster at the bottom of that pool when you column pour?
It is chewing up that nice porous cement surface.
Yeah, and when it does that, it dissolves calcium carbonate, and it pulls out calcium hydroxide, which has a very high pH within the cement, which neutralizes some of the acid. So you get this illusion that you didn't change the pH as much. But that's really because you're not testing the pH a few hours later. You're testing it 7 days later, pool pros who do this on a once-a-week basis. So you actually think, hey, I reduced my alkalinity better, and then I come back and there's a high pH, so I didn't tank my pH. You absolutely tanked your pH.
But don't mind those weird marks and splotchy spots on the bottom of the pool.
Right. So what does a main drain do? Because if you have acid going straight down to the bottom, and let's say you pour a quart of acid to the bottom, what do you suppose the pH is right down there at the main drain where the acid's concentrated?
Let's just be simple and say very low.
Yeah, that's an understatement. Okay, and what does a main drain actually do?
It pulls directly from the pool at the bottom into your main pool pump.
That's exactly right. So if it's going to do that, then we have to be aware that it's going to basically mainline acid. I actually can't find the photo very easily. Hold on. It's going to here it is. I found it. Yay. Sharing my screen now for those of you on YouTube. So there's the picture. And let's see here. Yeah. It's going to mainline acid straight through the main drain, and it's going to corrode a heater. So if you have copper staining in that spa, that's probably what happened. You had too much acid going through the circulation system. If you have degradation of a salt system or pump or anything like that, too much acid going straight through the plumbing system is never a good idea. It's the same reason you don't want to put trichlor in a skimmer. You do not want this to happen. You do not want acid to go straight to the bottom. It will etch. And if you look at the photo on the left, is it not suspicious that that white line at the bottom of that dark blue pool is exactly 1 arm's length around the curve of the perimeter of the pool? Clearly, someone walked around with their arm extended and poured acid as they walked, and it went straight to the bottom, and it damaged that pool.
I thought you meant to the left where that cool guy was pouring some acid into a measuring cup. That's the picture I was referring to.
Oh, well, that is that cool guy being the superstar, Jared himself. With gloves on, best practices.
With gloves, glasses, and measuring cup, everybody.
Oh, yeah.
Okay,
and he was squinting. Yeah.
To move on here, the biggest concern that I get on the hotline here is a lot of times it's on new fills, or if you're on a well or you're in an area where the alkalinity out of the tap is high. And it can be a real challenge to maintain a pool that has constantly high alkalinity being introduced and driving it up. And quite honestly, I don't really envy anybody that battles that situation because it is hard. There's things that you can do to combat this, and that's kind of what we're going to get into here, and honestly, probably wrap it up right after. But especially on a new fill and a new startup, let's say you have an alkalinity at 200 or higher, which is not uncommon in certain places and areas, and it's definitely something we battle.
Yeah, Northern California, we hear about it all the time. Upstate New York has this too.
Which everybody wants to know, well, how can I get it down? And my answer is always slowly. You have to do it slowly, because if you try to rush it, you're going to burn like he just showed you in that photo with the acid going down to the bottom. If you get too much acid in your pool, you're going to drive down the LSI too much, which is going to create a adverse reaction with that surface and pool calcium hydroxide, especially if it's a new surface, and you're going to have a bigger problem to manage besides high alkalinity after that.
That's correct. So there's a few things that you can do. And Jared brings up a very good point. This is a common question that we get at Orenda. How are you supposed to go from 280 alkalinity out of the tap to a respectable number, after the startup, after 30 days or something? Because it's great that you have that 280 out of the tap if you're trying to start up a plaster pool, isn't it, Jared?
Yeah, for plaster, it's great. We just can't maintain pH very well at that level.
Well, it'll go super high. The pH ceiling is very high. So you have to work it down. So what I always tell people, to be a little bit more specific than Jared, is he says slowly. I say don't go more than 20 parts per million at a time. In fact, you should aim for 10 to 15 parts per million of reduction at a time. If you do so, then it's going to be a lot easier to not lose control of that pH. If you put too much acid in, the pH bottoms out. So the key here is to go slow and dilute like crazy. Dilute, 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 dilute. That is going to allow the acid to go as slowly as possible down through the water and neutralize as much alkali as it can before it gets to the bottom and touches concrete. Would you agree with that, Jared?
Yeah, and the hope is that it's mixed in and diluted enough to where it never really reaches the bottom per se. It's just dissolved and diluted in the water, and it's going to continue flowing and moving around, right?
Right. And if you do it right, that's exactly what's going to happen. So when in doubt, use a little less acid than you think you might need and dilute more. 10 to 1 is recommended. 20 to 1 is even better. 30 to 1 is even better than that.
Yeah, when I say slowly, I'm referring to customers and people that are doing a startup. So they're basically at this job daily, right, for the next 7 to 10 days. And you want to reduce that daily, slowly. And it could take up to 2 weeks, to get that alkalinity level down. But the worst thing you can do is try to speed this process up by adding more acid. That's the gist of this conversation.
Amen. Amen. You will shoot yourself in the foot if you try to rush reducing alkalinity. Now, the startup barrel, if you're doing the startup, hold on. The startup barrel, you can put, a quart of acid in at a time in that barrel. And if you're filling that pool over the course of a couple of days, you can keep coming back every hour or so and add more, because that will slowly introduce that acid pre-diluted for you. And you can get actually a pretty big chunk of alkalinity reduced that way.
Yes. And the way that you can get this done faster, right? Because everybody's impatient. They want to get on to the next job. They want to get their water balanced under control as soon as possible. There are some pretty cool ways that you can speed this process up as much as you can, right? Because you are still going to be limited here. So one of those ways is aerate the water. What does that mean? Aerate the water.
Well, stir it up. Now, Jared, here's the thing. You've got a waterfall in your pool. You got a spa. You could turn those jets on. You could do all that stuff. But in order to do that, you have to circulate water. And that could be a risk, especially if you're heating the pool. So there are other ways that you can aerate and stir up that water as well. Those of you who have cleaners, vacuums that are automated, you can move water that way. You could put an air compressor in. You could find creative ways to keep that water moving. Doesn't have to be with your pump system.
Point your return jets up so they ripple the top of the water. You can actually find attachments that screw into a return that almost act like they have a spout and a fountain, and they just shoot water up in the air, and that'll aerate the water. And that'll actually increase the pH of your water pretty quick.
Yep, and it will not, because you're reducing the amount of CO2 in it, and it will allow you to lower your alkalinity more rapidly because it's not tanking the pH.
Yeah, so when you come back the next 5 hours later or the next day, if you're doing a startup, your pH should be pretty high, higher than where you were the day before, to where you can get more acid in the water.
That's exactly right, because you're converting bicarbonate and carbonates into carbonic acid, and then you're quickly off-gassing that carbonic acid to get it out, and you're completing that cycle faster. So the pH doesn't tank, and you're able to reduce in larger, faster chunks a very high alkalinity. So let's shift gears here and wrap this episode up. How do you raise alkalinity? We've already talked about how to reduce it, low and slow, lots of dilution with acid. How do you raise it, Jared?
Most 95% of people are going to say sodium bicarbonate, which is bicarb. That's how we refer to it.
Baking soda.
And
Yeah,
because in that cool little chart you showed, that is the range in which we are working within, right?
that is exactly right.
Bicarb. So little unknown fact, and I don't know how many people actually think about it, but
Hmm.
soda ash will also increase alkalinity, but it's mainly known for its increasing pH capabilities. That's what soda ash, in my opinion, is used for, is to raise the pH. I don't think of it as raising the alkalinity. If I want to raise alkalinity, I'm going to use sodium bicarb.
Well, it's a lot more concentrated. So by a lot, I mean 1,000 to 1,200 times more concentrated because pH is logarithmic. So here's an example from Robert Lowry's book. This is the IPSA Intermediate Training Manual. And let's see here. No, I'm sorry. This is the basic training manual. I've switched books here. On page 38, so if you have the book, you can check this out yourself. He's got a very convenient chart that shows what 1 pound of soda ash in 10,000 gallons of water does compared to 1 pound of bicarb. So let's say you have a pH of 7.4 and your alkalinity is at 80. If you put in a pound of soda ash, you are going to raise the pH by 0.53 of a pH point. Okay, so you'll go up from 7.4 to 7.93 with 1 pound. If you do that same pound, but with bicarb in that same pool, instead of going from 7.4 to 7.93, you're going to go from 7.4 to 7.426. You hardly make a change at all to your pH, but you will get your alkalinity up substantially. So you can raise your alkalinity. So according to this, let's see here, 1 pound of soda ash in 10,000 gallons will increase your total alkalinity by 11.3 parts per million. A pound of bicarb will do 7.3 parts per million, so it's not as concentrated. The difference is bicarb doesn't raise your pH much. So you can add a lot more bicarb, which is why the Orenda app recommends raising it with bicarb, not with soda ash. You could add pounds upon pounds of bicarb and not really spike your pH. If you add pounds and pounds of soda ash, Jared, what happens?
Cloudy water.
Yep, LSI violation all the way because you put in a very high pH product, the pH skyrocketed, and you precipitated calcium carbonate. So if you're going to
Which
raise
everybody
it,
that's wondering here, the pH of soda ash or sodium carbonate is roughly 11, and the pH of sodium bicarb is roughly 8.5. So there is a dramatic difference there.
yeah, it depends on the purity. This book says 8.3 to 8.5. Soda ash is 11.2 to 11.5. So you're spot on that.
That's why I clearly said roughly.
I know.
Come
Well, you
on.
did. Hey, you know what? We are in the business of clarity, Jared.
Yes.
Shape up. Shape up, Jared. I'm looking at you.
Oh, sorry.
We have an example to uphold here. We're on video this time. Keep that in mind.
I know I did my hair.
I know. Yeah, it looks great. Yeah, it looks great. Okay, so this has been episode 62. Is there anything else that you want to add about adjusting alkalinity?
No, I just think it's one of those things where people need to, we preach it all the time, right? Don't fight your water. If you try to fight this thing in a manner in which doesn't make sense, you're going to be beating your head up against the wall. Just understand and explain this to your customers. You have to explain it to your customers. It's going to take time. You're
Mm-hmm.
managing the LSI. It's going to take time. If it takes an extra trip, just be very upfront and honest about it. And if it's more money, it's more money. I mean, people, this is just reality, right? But you have to be upfront about all of it. Don't try to rush it.
Yeah, one of the worst things you can do, rushing it on the downside is way more consequential than rushing it on the high side, like adding bicarb too fast. But there are consequences in both directions here. If you add it too fast and it starts clouding up the water, stop. Give it time. You're going too fast.
Yep.
Slow down, dilute it more, mix it longer, go to another side of the pool. And it's going to be hard the colder the water it is. It's going to be harder to dissolve soda ash or sodium bicarb. Not calcium chloride. Calcium dissolves really well in cold water. Bicarb does not. So just keep these things in mind. Take your time, and if you follow the app, you don't have to dose it all at once. You don't. That's the total dose that you're going to need. So just keep track of what you're doing, put it in your software or whatever you use, and methodically address total alkalinity over time. Jared, thank you so much for being on here as my guest this time.
Yes.
Ha
It's
ha.
your guess now. Because, that was the shortest episode we've done in a long time.
Yeah, when you administrate, we're more efficient. You're right. You should probably administrate more episodes. Hey, by the way, to those of you listening, we are always grateful, and I want to thank you again. I've been getting a lot more emails at podcast@orendatech.com. Some great ideas coming in, and I appreciate that because this summer we are looking for things to talk about because there's only so much you can talk about in pool chemistry. So thank you for all the ideas. Thank you for listening to this. And until next week, we'll see you out there. Good luck this season. Take care, everyone.
Thank y'all.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.